Hello everyone, I'm Shlok Patak from section 424 IM.
Hello, my name is Abhijit.
And I am using. Today we are here to present our project that is dish scheduling.
Should the service to minimize seek time and maximize throughput. Understanding these algorithms theoretically can be a bit challenging, in which Simulator comes in, providing an interactive and visual way to see how each algorithm behaves with different input parameters. This project is built using standard web technologies like HTML, CSS, and JavaScript. This simulator requires no frameworks or complex build tools. The project consists of 5 core files: index.html, the semantic markup structure of the website; style.css, clean and responsive styling with modern CSS; app.js, the main application logic handling with UI interactions and visualization; algorithm.js, pure implementation of all scheduling algorithms that are included in this project; and verify algorithm.gf. This is just a test file for testing the algorithm's correctness. The simulator implements 4 classic test scheduling algorithms. First one is SCFS, first come first serve, processes requests in the order they arrive. SSTF, shortest seek time first, always services the nearest request next. Scan, elevator algorithm, moves the disk on in one direction, servicing request until reaching the end, then reverses. C-scan, circular scan, similar to scan but returns to the beginning without servicing requests on the return trip. Plus, there is a compare all mode that runs all algorithms simultaneously for side-by-side analysis. It's what the website or the project looks like. There are some key features that are in this website and project, that there are custom input requests that you can put in, like for example, that is already written over there as an overlay at 98 from 183. So you can put in your request from a separator for your own customization. And there is a direction control option if you use C-scan or scan option. Also, the time is calculated in real time and the total seek distance, average seek and through. And if you run this, like let me, for example, select FCFS and load the sample. This is the sample that has been loaded, and if I execute the sequence, you can see the visualization of all the, because we use the load sample option. So it compares all with the default values that are already there in the program. So you can see visualizes the data in a chart format in which you can easily see which one performed the best, and they're also color coded so you can differentiate between them easily. And also this website is responsive, so you can also use it in a mobile phone and it will give you the same results as it would on a bigger screen or a computer. So for the working of this project, I'll tell you how it works and how you can use it for your own. So on the left side, we have a simulation input in which you can put your request. For example, in here I have written 98, 180, 37, 122, and these all are format separated variables. So you can change these to any way you like. You can click on load sample to load the sample that is given, but you can also add more like this, or you can change some values if you want to. Like instead of 14 here, I would like to put 60. Instead of 183 here, I would like to enter 16 also. And you can set the initial to 0 or any value there. For example, I'm going to enter 25 then, and the max blend I will put it to 198. And because we are comparing all of that, if you use a single one, that is also okay. But in FCFS and SSTF, cannot select a direction. You can also see here it is written every direction is ignored for FCFS and SST. And in scan and see scan option, you can choose direction if you want it to the right or towards the left. So let's start with FCFS, and we can just fill all these entries and just click on execute sequence. So it will display a graph of the data and how the scheduling for behind this. And you can down here see the performance view of the algorithms comparison. In this case, we only use SCFS. So the total time received case was 504 and the throughput was 0.017. And you can also see the service sequence, how it went: 98, 16, 37, and head part 25, 28, 16, 37. And the total seek distance was 504. And here you can also see it in a simpler format if you would not want to see this in detailed form. And also you can select scan, and let me change it to left for example. and it will show me how fair. So it will show me graph, and I can hover over every single one of the datas and points, and I can see what happened there. And also this one took 149 seek and 0.0604 throughput, and you can see the hit path, and down here you can also see it in easier in a table form.
Let us understand with an example. Let's suppose we have taken a random request queue. We are loading it and we are running it. Our request queue is 98 and this all. And our initial head position is 53. We are comparing all of four of them. First, FCFS. The first who come, they will serve first. Like our initial position is 53. After 53, 98, 98, then 183 is coming. So we are serving 183. So on, we are going. So the total seek distance is 640 in this case. Now SSTF. In SSTF, we see which is nearest to our initial position. For example, our initial position is 53. After 53, which is nearest to 53 is 65. So we will go with 65. After 65, 67 is nearest to 65. And after 67, 37 is nearest. So we go like this to the end, to the maximum one. So the total seek distance is 236 in this case. S scan. In S scan, we take the number which is greater to the initial position and go till the highest. After reaching the highest, we go back to the just smaller to the initial position. For example, 53 is our head position, so we go 65. After 65, we go 67, then 98, and reach till 183. So our max length is 199. After 199, we goes to just smaller to 53, that is 37. And after 37, the smaller than 37, then 40 till the end. That and the total seek distance will be 331 in S scan. In C scan, it is similar to scan, but when we are reached to the maximum, then we go to minimum of them. For example, after 53, 65, 67, it goes till 183, but after reaching 183, it goes to 0 and start with which is least among them, that is 14, and after that 37. So the total seek distance is 382. This is where a tabular form where we compare all of them, total seek distance average. So the best for this sample is SSTF because it is given 236 total seek and the average is 29.50. Thank you.